Okay, for the purposes of constructing a modified box plot, outliers are defined as data values that are either above the third quartile or below the first quartile by an amount of at least 1.5 of the interquartile range. Okay, now remember the quartiles, these are percentiles that separate each 25% of the data set. So if we're talking about a normal distribution, and we know how to work with areas and probabilities and z-scores dealing with the normal distribution. If we're talking about the first and third quartile and the distance between these two, which would be the interquartile range, well, that means we're separating the center 50% of the distribution of data. All right, so this would be Q1 and this would be Q3, which means if there's 50% in the middle, the other 25% above, and the other 25% of the data is below. Okay, so here's our setup. So remember Q2, which we don't need for this problem, but Q2 is the median of the data set, and with the normal distribution that's also equal to the mean because it's symmetric. Now, we need to find, in this case, we're dealing with the normal distribution, so Q1 and Q3 are going to be z-scores. So we need to find the z-score here. Like what is the z-score for Q1? Okay, well, we have a function for this. This is the normal inverse function. And since we're dealing with z-scores, we need to use the standard normal inverse function. So that's equal norm.s.inv, and the area to the left, or the probability, is 0.25. Okay, so that's Q1. For a normal distribution, Q1 separates the lower 25% of the data, and so that z-score is 0.6745. It's if we round to 4 places. Okay, and then same thing, we need the third quartile, and the third quartile is separating the lower 75% of the data from the upper 25%. So let's use equal norm.s.inv, or again, this will give us the z-score if we know the area, and our probability, or our area, is 0.75. Okay, and we should get exactly the same number, just positive, because the normal distribution is symmetric. Okay, so now we have our first quartile, the z-score that separates the lower 25%. We have our third quartile, the z-score that separates the lower 75%. Okay, so now the interquartile range. Now the interquartile range is Q3 minus Q1. That's the definition of interquartile range. And we have Q3 and we have Q1 right here. So for the interquartile range, let's say this should be equal to Q3 minus Q1. Okay, so that's the distance between Q3 and Q1. All right, next, to define outliers, we need 1.5 of the interquartile range. Okay, so we just found the interquartile range, so let's take this number right here. Let's multiply this by 1.5. So we can say equal 1.5 times the interquartile range. Okay, so, and that's what we're talking about here. Above Q3 by an amount greater than 1.5 of the interquartile range, or below Q1 by an amount greater than 1.5 of the interquartile range. Okay, so that's what we're going to be using this number for. Okay, so we'll take, so let's switch to black here. Okay, so this z-score right here will be the first quartile minus 1.5 of the interquartile range. And then the probability, so if this will be in black, this will be the probability of an outlier on the low end. Probability of small outlier. And then we'll do the same thing. We'll take Q3 and we'll add 1.5 of the interquartile range. We'll get a z-score there. And that will be the probability of a large outlier. Large outlier. So you could have an outlier on the low end, you could have an outlier on the high end. Now, because of the symmetry of the normal distribution, the probability of an outlier on the low end and the probability of an outlier on the high end, these two are going to be equal. So if we calculate one, we could double it, and that'll give us the total of these two probabilities. So what I have over here is Q1. So what I've typed in was Q1 minus 1.5 of the interquartile range. Okay, so we have Q1 is here. Okay, so let's say this is equal to Q1 minus it's not letting me select that. Q1 minus B12. Okay, so that's Q1 minus 1.5 of the interquartile range. Okay, so that is this z-score down here to negative 2.69796. Okay, so this is that z-score right there. And now the black area, or the probability of an outlier on the low end, well, now we have the z-score, we need that area. We need that black area, that's the probability. Okay, so that should be equal to norm.s.dist, the normal standard distribution. So that'll give us probability. That's our goal. So that's our goal. The goal of this problem is to find probability. Okay, so we have our z-score. So right here, cumulative, yes, we always say yes for continuous distributions. Okay, and that is it. That is that's almost it. That's the area to the left of this z-score, or this is the probability. This is the probability of having an outlier on the low end, but we also have outliers on the high end, so we have to double this. So we could equal 2 times this number. Yeah. All right, looks good. And I think in this problem, if I recall, the directions said round your answer to 4 decimal places. So it looks like final answer 0.0070, or 0.7%, that a randomly selected value from a normally distributed data set will be an outlier. Okay, that does it for this one. Hope it helps.